Hello and welcome back. There's one final housekeeping item that we want to cover before we leave this packet, which is to explain why we can use that procedure we did to solve separable differential equations. And it turns out that we can justify that procedure using the chain rule. So what we'll do is we'll start with the integral of h of y dy equals the integral of g of x dx and work backwards to our separable differential equation. And by doing this, we'll be able to then reverse these steps and go from our separable differential equation into the integral of h of y equals the integral of g of x. So if we start from the integrals equal to each other, we can take the derivative of both sides with respect to x, and they'll still be equal. Now on the right side, we just have the derivative of the integral of g of x dx. That one, the derivative and the integral will undo each other in a moment. But we can't do that with the left side yet, because here we have the derivative with respect to x of a function of y, right? This integral will produce a function of y on the left side. So what we can do to get around that is use the chain rule. The chain rule says that we can, instead of taking the derivative of this with respect to x directly, we can take the derivative of this integral with respect to y and then multiply it by the derivative of y with respect to x. So we can break up this derivative with respect to x into two parts. The derivative of our original thing with respect to y, and then times the derivative of y with respect to x. So that's using the chain rules, by the chain rule. Then we can use the fundamental theorem of calculus to handle the derivative of the integral on both sides of the equation. The derivative of the integral of this function right here, h of y, with respect to y, is going to just be h of y, because the derivative and the integral now can undo each other, now that we're all talking about y, everything with respect to y. You'll still have this dy dx part right here, and on the right side, the derivative and the integral will undo each other as well, because there you're all talking about x. So we have h of y times dy dx equals g of x. All we have to do is then divide by h of y. And by Jove, we've done it. So that justifies why we can go from this differential equation dy dx equals g of x over h of y, that separable differential equation, why we can turn that into the integral of h of y dy equals the integral of g of x dx. Thanks for watching, and see you in the next video.